For decades, the story of the Berbers seemed settled. North Africa's oldest surviving people, the Amazigh, were understood as a broadly Mediterranean population, genetically rooted in the Near East, shaped by the same migrations that built the ancient world around them. Textbooks drew a clean line, from the Levant to the Maghreb, from forager to farmer to the people we see today. The genetic markers seemed to confirm it. The cultural continuity reinforced it. It was a tidy story. And it was wrong. Because when scientists finally extracted DNA from the bones of the people who lived in North Africa 15,000 years ago, the genome that came back didn't match anything on Earth. Not fully Near Eastern, not fully African, not European. Something else entirely, something that shouldn't exist under the old model, was staring back from the data. And the deeper researchers dug, the stranger the ancestry of the Berbers became. To understand what changed, you have to understand what everyone believed and why they believed it. For most of the 20th century, the dominant view held that North Africa's indigenous population descended primarily from waves of migrants who crossed into the Maghreb from the eastern Mediterranean. The reasoning was straightforward. Berber languages belong to the Afro-Asiatic family, a linguistic group stretching from the Horn of Africa through the Middle East. The most common paternal lineage among Berber men, a Y chromosome marker called E1b1b, was traced to an origin roughly 42,600 years ago, likely somewhere near the Horn of Africa or the Near East. Its subclade EM81, found at frequencies exceeding 80% in some Berber communities, appeared to confirm a deep, coherent ancestral signature. On the maternal side, mitochondrial haplogroups U6 and M1, both associated with back-to-Africa migrations from Eurasia in Upper Paleolithic times, reinforced the picture. The model worked. Genetically, culturally, linguistically, the Berbers fit neatly into a narrative of westward migration from the eastern Mediterranean, followed by millennia of relative isolation. And the tools of the time reinforced that confidence. For most of the 20th century and into the early 2000s, researchers relied primarily on mitochondrial DNA, the small circular genome inherited only from mothers, and on Y chromosome markers passed only through fathers. These are powerful tools, but they each trace only one ancestral line, mother to mother, father to father, ignoring the vast majority of the genome that recombines every generation. It was like mapping a continent by following a single river. A paper here or there noted anomalies that didn't fit. An unexpectedly high frequency of sub-Saharan maternal lineages among the Tuareg, reaching 82% in some samples. A puzzling scarcity of European ancestry despite millennia of geographic proximity across the Strait of Gibraltar. The Sami of Arctic Scandinavia, of all people, sharing a mitochondrial branch with Berbers, a haplogroup called U5b1b, aged only 9,000 years, traced by Achille and colleagues in 2005 to the Franco-Cantabrian refuge of Ice Age southwestern Europe. That finding alone should have signaled that the story was far more tangled than any simple eastward migration model could accommodate. But it was treated as a curiosity. A footnote. The deeper problem was structural. Without whole genome data from ancient individuals, researchers could only work backward from living populations. And living populations carry the accumulated signal of every migration, every admixture event, every bottleneck, layered on top of each other like paint on a canvas. Separating those layers required something no one had: DNA from the people who lived in North Africa before those layers were added. And North Africa's hot, arid climate destroys DNA faster than almost any environment on Earth. The old consensus didn't survive because it was correct. It survived because the technology to test it didn't yet exist. Then came the bones from Taforalt. In 2018, a team led by Marieke van de Loestrecht at the Max Planck Institute achieved something no one had done before. They extracted and sequenced nuclear DNA from 7 individuals buried in Grotte des Pigeons, a cave near the town of Taforalt in eastern Morocco. The remains were directly radiocarbon dated to between 15,100 and 13,900 years before present. This was the oldest nuclear DNA ever recovered from the African continent. The expectation was clear. These Iberomaurusian people, makers of fine microlithic stone tools, who had occupied the cave from roughly 23,000 to 12,000 years ago, would anchor the ancestral baseline. They would show what the Proto-Berber gene pool looked like before the Neolithic, before farming, before everything that came later. And in a sense, they did. But the baseline wasn't what anyone predicted. When the team modeled the ancestry, the Taforalt individuals broke into 2 distinct components, 63.5% related to Levantine Natufian hunter-gatherers, and 36.5% related to sub-Saharan African populations. That alone was surprising, but the real shock came from the sub-Saharan component. It didn't match any known living population. Not West Africans, not East Africans, not the Hadza of Tanzania, though they came closest. This was ancestry from a population that appears to have left no unmixed descendants. A genetic ghost. The implications were immediate. 15,000 years ago, North Africa was not the isolated Mediterranean corridor the old model described. It was a crossroads, connecting the Levant and sub-Saharan Africa in ways no one had anticipated, and the connections ran deeper than anyone suspected. Before we go further into what the ancient DNA revealed, if this discovery is as fascinating to you as it is to us, subscribe so you don't miss the next chapter. The story is about to get stranger. Because the Taforalt finding raised a question that couldn't be answered with a single cave. If this was the ancestral baseline, what happened next? How did the modern Berber genome take shape from this unexpected starting point? In 2023, Luciana Simões and colleagues at Uppsala University provided part of the answer. They sequenced ancient DNA from 9 individuals across multiple Moroccan sites spanning the Stone Age to the Neolithic, and published their results in Nature. What they found was a layered process unlike anything documented elsewhere in the world. Up until approximately 7,500 years ago, a group of local foragers in northwestern Africa had maintained remarkable genetic continuity, their ancestry closely matching the Taforalt profile for at least 8,000 years, possibly much longer. Then, suddenly, foreign DNA appeared. At the site of Kaf Tat El Gar, individuals dating to approximately 7,200 years ago carried up to 80% ancestry from European Neolithic farmers, people whose own ancestors had dispersed from Anatolia through Europe before crossing the Mediterranean from Iberia. This was not a trickle of contact. This was a demographic event. But here's what makes the Berber story unique. The local foragers didn't vanish. Within a few hundred years, they adopted farming themselves, and the two populations, newcomers and locals, coexisted side by side. Simões called it a phenomenon not seen anywhere else in the world. The usual Newman pattern, where farmers replace or absorb hunter-gatherers almost entirely, did not fully apply here. Berber foragers held on. Then, around 6,300 years ago, a third wave appeared, this time from the Levant, arriving alongside the introduction of pastoralism. 3 distinct ancestry sources, layered across barely 1,000 years, each one leaving its signature in the genome. And the map was about to get more complicated still. In 2025, 2 separate studies published in Nature added dimensions no one had seen. Mark Lipson and colleagues at Harvard, working with Ron Pinhasi at the University of Vienna and others, sequenced genome-wide data from 9 individuals spanning the later Stone Age through the Neolithic in Algeria and Tunisia, the eastern Maghreb. The results were striking. While Western Morocco had experienced massive demographic shifts, with European farmer ancestry reaching 80% at some sites, the Eastern Maghreb told a completely different story. Populations in Tunisia and Algeria retained largely local forager ancestry throughout the Neolithic, absorbing only modest contributions from European farmers, roughly 20%, and Levantine groups. These eastern communities showed a continuity the West did not. They had resisted the wave. The second 2025 Nature paper, led by Salem and colleagues, reported ancient DNA from an even more unexpected source, the Green Sahara. Two approximately 7,000-year-old female individuals from the Taforalt rock shelter in southwestern Libya carried the majority of their ancestry from a previously unknown North African genetic lineage. This lineage had diverged from sub-Saharan African populations around the same time as the out-of-Africa dispersal, roughly 50 to 70,000 years ago, and then remained isolated throughout most of its existence. It was related to the Taforalt ancestry, but distinct, a deep branch of humanity that had persisted in North Africa while the rest of the world was being settled. Consider what that means. While Homo sapiens was colonizing Europe, reaching Australia, crossing into the Americas, a separate population was living in North Africa, largely cut off, for tens of thousands of years. The Taforalt individuals showed 10 times less Neanderthal ancestry than Levantine farmers, but significantly more than contemporary sub-Saharan genomes. They occupied a genetic position that exists nowhere in the modern world. And the evidence suggests that pastoralism, the herding of cattle and goats that would reshape the Sahara, spread into this population through cultural diffusion, not through the replacement of one people by another. They learned. They adapted. They survived. Now step back and look at what the evidence actually shows. 3 proof beats. First, what the data reveals. The Berber genome is not one story. It is at minimum 5 distinct ancestral layers, an ancient autochthonous North African lineage diverging near the dawn of modern human dispersal, a Levantine-related component present by 15,000 years ago, European Neolithic farmer ancestry arriving approximately 7,500 years ago, a second Levantine wave around 6,300 years ago, and later Arabian gene flow from the 7th century onward. Each layer arrived through a different mechanism, at a different time, through a different route. Second, what this rules out. It rules out any single origin narrative for the Berbers. It rules out the idea that Arabization was merely cultural, as haplogroup J1 now accounts for roughly 30% of North African Y chromosomes. It rules out the assumption that the Neolithic transformation was uniform across the Maghreb, since Eastern populations resisted gene flow that overwhelmed Western ones. And it rules out the possibility that modern genetic snapshots can reconstruct deep history, because the sub-Saharan component found in Taforalt 15,000 years ago has no clean match among any living people. Third, what this implies about the people themselves. The Amazigh are not the product of a single migration or a single homeland. They are the result of North Africa functioning as a continental crossroads for 50,000 years or more. The foragers who maintained their genetic profile for 8 millennia while European farmers settled next door were not passive recipients of change. They were participants in one of the most complex demographic negotiations in human prehistory. But this story is far from resolved. The Green Sahara lineage raises questions that current data cannot answer. How far did this deeply divergent population extend? The Sahara, for thousands of years, was grassland dotted with lakes and rivers. If this population was widespread, where did they go when the desert returned around 5,000 years ago? Some geneticists suggest traces survive in modern West African pastoralist groups like the Fulé, who carry an estimated 30% ancestry from this ancient Saharan population. Others are cautious, noting that the sampling remains thin and that North Africa's brutal climate for DNA preservation means entire chapters may be permanently lost. There is also genuine debate about the direction of the oldest movements. Iosif Lazaridis and colleagues have argued that the Iberomaurusian population of Taforalt may have actually contributed ancestry to the Natufians of the Levant, not the other way around, estimating roughly 22% Iberomaurusian input in Natufian genomes. If correct, the arrow of influence doesn't just point from the Near East into Africa, it points both ways. North Africa was not merely receiving, it was sending. Meanwhile, the stark east-west divide within the Maghreb itself remains only partly explained. Why did Eastern Berber populations resist the Neolithic wave so effectively, while Western populations were demographically transformed? Some researchers point to the geography of the Strait of Sicily versus the Strait of Gibraltar. Different maritime distances, different opportunities for contact. Others suspect that the Eastern Maghreb's pastoral traditions, sheep, goats, land snails, wild game, created a subsistence base that made wholesale adoption of farming unnecessary. The full adoption of agriculture in that region may not have occurred until the first millennium BCE, thousands of years later than in the West. Today, a Berber woman in the Rif Mountains of Morocco and a Chawi-speaking man in the Oriz Mountains of Algeria may both identify as Amazigh. They share a linguistic family, a cultural heritage, a word, Amazigh, that means free people. But their genomes tell different stories. The Rifian woman may carry less than 3% sub-Saharan maternal ancestry, while a Tuareg in the deep Sahara may carry more than 80%. The Kabyle of Algeria preserve proportions of ancient forager ancestry that coastal Moroccans have largely lost. No single genetic profile defines the Berbers, because the Berbers were never a single genetic event. And that is perhaps the most profound rewriting of all. The people who call themselves free were shaped not by one origin, but by the accumulated weight of every human movement that ever crossed the space between the Mediterranean and the Sahara for 50,000 years. If this hidden chapter of history changes how you see the ancient world, subscribe to explore more stories the evidence is only now revealing. Here is the question the DNA cannot yet answer. Somewhere in North Africa, possibly beneath the sands of a dried lake in the Sahara, lie the remains of the ghost population that contributed a third of the Taforalt genome 15,000 years ago, a people who left ancestry in ancient bones, but apparently no unmixed descendants alive today. If we ever find them, what else about the human story will we have to rewrite?